thing that will occur in the future. This facet of statistics. Previous chapter we already discussed about descriptive statistics. Descriptive statistics where it is about summarizing data collected from past events. And we now turn to the second facet of statistics, namely computing the chance of something that will occur in the future. This facet of statistics is called inferential statistics. It helps us to make decisions because there are uncertainty in decision makings. It is important that all the known risks involved be scientifically evaluated. This evaluation is the probability theory, which has often been referred to as the science of uncertainty. The use of a probability theory allows the decision maker with only limited information to analyze the risk and minimize the gamble inherited. What is probability? In general, probability is a number that describes the chance that something will happen. Probability is the measure of the likelihood that an event will occur in a random experiment. Probability line is a number line that goes from 0 to 1. The closer a probability is to 0, the more unlikely for the event to happen. The closer the probability is to 1, the more likely for the chances of the event to happen. There are 4 keywords in the study of probability. The first one is experiment. It is a non-deterministic process that has a number of distinct possible outcomes, such as tossing a coin. And the second one is outcome. It is the result of the experiment. The example is heads or tails. The third one is sample space. It is the set of all possible outcomes of an experiment, such as when we are tossing a coin, the sample space will be S equals HH, HT, TH, TT. H is head and T is tails. And for the fourth one, which is event, it is a subset of the sample space. For example, if we were to determine the outcomes that has only head or H, the event will be E equals HH, HT, and TH. On to the question, what is a simple definition of probability? What is a simple definition of probability? Time's up. Contingency tables is a table that is used to classify sample observations according to two or more identifiable characteristics. A contingency table is a cross-tabulation that simultaneously summarizes two variables of interest and their relationship. The level of measurements can be nominal. For example, a survey of 150 adults classified each as to gender and the number of movies attended last month. Each respondent is classified according to two criteria: the number of movies attended and gender. On to the questions. What is a contingency table? What is a contingency table? Time's up. Approaches to assigning probabilities. First is objective probability and second is subjective probability. For the first objective probability, it is classical probabilities. It is based on the assumption that the outcomes of an experiment are equally likely. Second, mutually exclusive. The occurrence of one event means that none of the other event can occur at the same time. Third, collectively exhaustive. At least one of the events must occur when an experiment is conducted. Historically, the classic approach to probability was developed and applied in the 17th and 18th century in the game of chances. On to the question, mention a game of chance that uses a classical approach to probability. question. Mention a game of chance that uses classical approach to probability. Time is up. Lotteries. The classical approach to probability can also be applied to lotteries. In South Carolina, one of the games of education, lottery is Pick 3. A person buys a lottery ticket and selects 3 numbers between 0 and 9. Once per week, the 3 numbers are randomly selected from a machine that tumbles 3 containers, each with balls numbers 8 through 9. One way to win is to match the numbers and the order of the numbers. Given that 1,000 possible outcomes exist, 000 through 999, the probability of winning with any 3-digit number is 0.001 or 1 in 1,000. Empirical probability is a probability of an event happening in the fraction of the time to similar events that happened in the past. Law of large numbers. Over a large number of trials, the empirical probability of an event will approach its true probability. If we were to flip a coin, the result of each toss is either a head or tail. With just one toss of the coin, the empirical probability for heads is either 0 or 1. If we toss the coin multiple times, the probability of the outcomes of heads will approach 0.5. The following table reports flipping a coin 1 to 10,000 times and then computing the relative frequency of heads. As we increase the number of trials, the empirical probability of heads appearing approaches 0.5, which is its value on the classical approach to probability. Subject probability is the likelihood probability of an event happening that is assigned by an individual based on whatever information is available. Illustrations. 1 is estimating the likelihood of the New England Patriots will play in the Super Bowl next year. 2. Estimating the likelihood you will be married before the age of 30. And 3. Estimating the likelihood the US budget deficit will be reduced by half in the next 10 years. Now on to the questions. Estimate your own probability about any opinions and information. Now on to the questions. Estimate your own probability about any opinions and information. Time's
We
up.
have defined probability and described the different approaches to probability. We turn our attention to computing the probability of two or more events by applying rules of addition. There are two rules of addition, the special rule of addition and the general rule of addition. We begin with the special rule of addition. To apply the special rule of addition, the events must be mutually exclusive. Recall that mutually exclusive means that when one event occurs, none of the other events can occur at the same time. If two events A and B are mutually exclusive, the special rule of addition states that the probability of one or the other events occurring equals the sum of their probabilities. This rule is expressed in the following formula. Probability of A or B equals PA plus PB. For the three mutually exclusive events is written probability of A or B or C equals PA plus PB plus PC. The complement rule. It is used to determine the probability of an event occurring by subtracting the probability of the event not occurring from one. This rule is useful because sometimes it is easier to calculate the probability of an event happening by determining the probability of it not happening and subtracting the result from one. Notice that the events A and not A are mutually exclusive and collectively exhaustive. Therefore, the probabilities of A and not A sum to 1. So the formula is probability of A equals 1 minus probability of not A occurring together and at the same point in time. Addition formula is probability of A or B equals PA plus PB minus P of A and B. On to the question, what is the definition of joint probability? What is the definition of joint probability? What is the definition of joint probability? Okay, time is up. In the rules of addition, we found the likelihood of combining two events. In these rules of multiplication, we find the likelihood that two events both happen. There are two rules of multiplication, the special rule and the general rule. The special rule of multiplication requires that two events, A and B, are independent, but the two events are independent if the occurrence of one event does not alter the probability of the occurrence of the other event. The independence refers to the occurrence of one event has no effect on the probability of the occurrence of another event. One way to think about independence is to assume that events A and B occur at different times. For two independent events, A and B, the probability that A and B will both occur is found by multiplying the two probabilities. This is the special rule of multiplication and is written symbolically as probability A and B equals PA PB. And for three independent events, A, B, and C, is written symbolically as probability of A and B and C equals PA, PB, PC. We move to the general rule of multiplication. So if two events are not independent, they are referred to as dependent. We use the general rule of multiplication to find the joint probability of two events when the events are not independent. For example, when event B occurs after event A occurs, and A has an effect on the likelihood that event B occurs, then A and B are not independent. The general rule of multiplication is written as probability of A and B happening equals to probability A happening times probability B happening given A has already occurred. And for the three events is written as probability of A and B and C equals to probability of A multiplied by probability of B given A multiplied by probability of C given A and B. On to the question, what is the difference between special rule of multiplication and the general rule of multiplication? On to the question, what is the difference between special rule of multiplication and the general rule of multiplication? Okay, time is up. The principles of counting. If the number of possible outcomes in an experiment is small, it is relatively easy to count them. There are 6 possible outcomes, for example, resulting from the roll of a die. But if, however, there are a large number of possible outcomes, such as the number of heads and tails for an experiment with 10 tosses, it will be tedious to count all of the possibilities. To facilitate counting, we discussed 3 formulas: the multiplication formula, the permutation formula, and the combination formula. We begin with the multiplication formula. There are m ways of doing one thing and n ways of doing another thing. There are m times n ways of doing both. In terms of a formula, it is total number of arrangements equals m times n. This can be extended to more than 2 events. For 3 events, the total number of arrangements equals m times n times o. Next is the permutation formula. It is applied to find the possible number of arrangements when there is only one group of objects. Permutation refers to any arrangement or r objects selected from a single group of n possible objects. So the formula to count the total number of different permutations is NPR equals to n factorial divided by n minus r factorial, where n is the total number of objects, r is the number of objects selected. So we moved on to the combination formula. If the order of the selected objects is not important, any selection is called a combination. The formula to count the number of r object combinations set from n objects is NCR equals to n factorial divided by r factorial times n minus r factorial. On to the question, what is the difference between permutation and combination formula? On to the question, what is the difference between permutation and combination formula? Okay, time is up. Diagram is a tool to help calculate and provide a visual representation of probabilities. There are two types of events. First, the conditional probabilities, otherwise known as dependent events, are the typically increased chances of an event taking place because another event has already happened. More specifically, it is usually occur if other events occur. Second, the independent events. It is have no effect on the occurrence of probability of other events. Also, their probability of occurrence is not dependent on or influenced by the occurrence of other events. Each tree diagram starts with an initial event, otherwise known as the parent. From the parent event, outcomes are drawn. To keep it as simple as possible, let's use the example of flipping a coin. The act of flipping the coin is the parent event. From there, two possible outcomes can occur: drawing heads or drawing tails. The tree diagram would look like this. The tree diagram can be extended almost infinitely to account for any additional probabilities. For example, this. Second string of possibilities represents a second coin toss. The first can be either heads or tails. However, if it's heads, there are two possible outcomes for the second toss, and if it's tails, there are two also possible outcomes. Bayes' theorem is a way of finding a probability when we know certain other probabilities. The formula is probability of A given B equals to probability of A multiplied by probability of B given A divided by probability of B. For an example, let us say P of fire means how often there is a fire, and P of smoke means how often we see smoke. Then P of fire given smoke means how often there is a fire when we can see smoke. And P of smoke given fire means how often we can see smoke when there is a fire. And the dangerous fire are rare 1%, but smoke is fairly common 10% due to barbecues, and 90% of dangerous fire makes smoke. So we can then discover the probability of dangerous fire when there is a smoke. P of fire given smoke equals to P of fire multiplied by P of smoke given fire divided by P of smoke equals to 1% multiplied by 90% divided by 10%. It is equals to 9%. On to the question, what is the difference between conditional probabilities and independent events? And what is Bayes' theorem? On to the question, what is the difference between conditional probabilities and independent events? And what is Bayes' theorem? Okay, time is up. Okay, guys, that's all for the survey of probability concepts. See you guys next time.